So, basically, Bill and the team suggested that I run a kind of Q&A session, I guess, with some of our experts here from the community here. And to be honest, I'm gonna run it in a sort of free-form kind of way. We did send some questions out to our panel here and to kind of prime the pump. But what I'd like to do is just have each of you maybe initially introduce yourselves and then talk about what you see 5 years from now in HPC, obviously in the context of where you work and what you're doing. Take about 5, 6, 7 minutes, to kind of give that perspective, whatever you're comfortable with. And then from there, I might ask some questions, or I might put it out and let the audience ask some questions. So I don't know if you're lined up. No, you're not, because I know. How did you go out of order? But please, why don't we begin on the end?
Okay. All right. Hello, everybody. My name's Phil Crawford. I work for Chevron in Houston. So a little bit about me. I've worked for Chevron for about 12, 13 years now. Previously was Unical. Unical got bought by Chevron in 2005. So I've really been with Chevron and legacy companies since 1999. I'm a HPC administrator. I look after a number of our HPC clusters. Just a little bit about Chevron, high performance computing. We currently have around about 2,900 nodes. It's about 40,000 to 50,000 cores right now, and that includes hyper-threading cores. I'll make that distinction right now. We don't have hyper-threading turned on everything, but we do on quite a number of our machines. As far as storage goes, we are currently moving more towards Panelists. We have about 2.7 petabytes of Panelists storage and about 600 or so terabytes of Lustre left. We've just decommissioned a 400 terabyte Lustre file system. We're moving primarily to Panelists just for ease of use. Some of the difficulties that we'd encountered with Lustre and some of the uncertainty a couple of years ago, certainly when Sun was taken over by Oracle and what Oracle's direction with Lustre was. It seems a lot more stable now, especially now that WAM Cloud's been bought by Intel. So a little bit what we do and what we see as future in HPC. GPUs is a big focus for us. We do a lot of seismic processing, which requires that we use GPUs for currently, and the new sort of technologies of GPUs are being introduced. We'll certainly be interested in Mike and Kepler 2 when they come along very soon. We're trying to look at demand to be able to run jobs on demand and consolidate GPUs to see if we can pool GPUs and have GPUs on demand. But those again are something that's a little ways away. That's about it.
What about cloud? Do you see Chevron distributing jobs out to public clouds?
So certainly not to public clouds, no. Mm-hmm. One of the worries that Chevron currently has with cloud technologies, cloud use, is security of data. Security is a big concern. We do want to perhaps implement cloud-like technologies internally. So again, sort of on-demand resources. Whenever a user wants to run a job, it doesn't really matter where it is. We are trying to use PBS more and more to effectively peer between some of our PBS servers. But public clouds right now, no. We did some tests with backup via cloud, and those actually have they were sort of relatively successful, but not 100%, and not something that we are currently looking at continuing.
And actually, I think that's very common. I think this concept of private clouds, in the more near term at least, which is till 5 years, I think is something a lot of sites and companies are really thinking about for all the reasons that you said. Do you see consolidation of sites? I don't know if you have multiple sites, and if you head towards cloud, you can consolidate more and be more effective
So I've not run, I was on vacation last week in the UK when I got this request, so I'm not able to provide any sort of slides, and I've not run anything past the...
We don't need slides.
Well, I've not been able to run any sort of information past the powers that be to bless what I can say, but we are consolidating a lot of our data centers to a single North America data center.
Yep.
So that will hopefully give us the ability to consolidate some clusters. Houston already was by far the largest, or is by far the largest. We'll move data center in San Ramon first to our North American data center, and then some of the smaller sites, and then ultimately Houston. So we will consolidate. Now, how it will turn out about who uses what resources,
that's the cloud.
That's the cloud, yeah. It's it's still very political, I think, within Chevron about we want our resources and we pay for our resources. Each group buys their own resources, and so they want it and they want to use it right now. Mm-hmm. And so we're trying to sort of overcome that even within the Houston site to try and pool resources as much as possible. We're moving currently towards models with PBS to do that.
Okay. I think you're in really big trouble with your management now.
Oh well.
Dale, how about if you introduce yourself and give us the overview?
So I'm Dale Talcott. I work at NASA Ames nearby, so a contractor actually. So, disclaimer, I'm speaking for myself. I'm not speaking for NASA, NAS, or CSC. I'm just myself. And my crystal ball is cloudy and not very reliable. So, don't make any investments based on what I say. So, our current system is a 1 petaflop system. Our expectation is that we'll be at 10 petaflops in 3 to 5 years. And that tracks Moore's law for flop doubling every 18 months. So that's sort of what we're looking for. We're assuming that we can get like a factor of 2 improvement in memory technology as part of our getting to 10 times where we are today. And that leaves a factor of 5 to get some other way. And I don't know what that other way is. So we're looking at GPUs. We've had like 64 nodes of GPU, 64 GPU nodes for over a year now. We have 1 user who uses them regularly, and a few have dabbled, but that's it so far. Most of our jobs are memory bound. We just know that, and we measured it. And so having to squeeze all of our data through the PCI bus doesn't work. GPUs are just, they're memory limited for our applications, so they're not helping us very much for most of our work. So we're looking at the Intel Phi processor. We have an RFP out for maybe even more. Anyhow, for 64 nodes with microprocessors. The current development environment for that is pretty awkward, but that'll get better. That's software, that'll get better. It's not going to be a limitation in the future. So far, though, the results are not impressive for us. So far, they'll get better, but we'll see about that. That's kind of a big question, because if we don't come up with something that gives us more cores in the same amount of space or the same amount of energy, where are we going to get our factor of 5? I don't know. Okay. So one possibility is to steal it from the cloud. And in fact, headquarters requires that we analyze work to see if we can benefit from the cloud with it. We've been doing that. Our testing so far does not show an economic justification for cloud use for most of our users. So we already have economies of scale. We have 182 racks, so they're kind of relatively inexpensive. You know, we're not buying one at a time. And typical applications have too much data to go slinging around. We'd have to have sort of dedicated resources in the cloud or long-term resources in the cloud where the data would live near where the computation is going to be, and buy the thing instead of paying somebody else, you know. So nonetheless, we do expect to have some kind of cloud bursting for certain users probably within the next year. We're going to do our own test cloud, and we'll validate how to do it and come up with ways to do it easily. And probably at that point, we will do some cloud bursting to Amazon, most likely. Okay, so some random thoughts about the next 5 years. We're running out of machine room space and power, and so we're very likely to go to container solutions just because containers are cheaper than machine room floors. And
containers inside of a big warehouse, or
no,
containers sitting outside?
It's California, they'd sit outside.
Well, it's better in Michigan, it's cold, so.
True, for containers, Michigan might be better, but snow's a problem, you know, snow load on your computer. Anyhow, if we go with containers, this is going to mean that we'll end up with multiple loosely connected systems, okay, rather than a single giant system. And that's actually better for users, it's better for admins because you can do partial updates, it's better all around, except we don't get a good top 500 number from it, and that makes it harder to sell to headquarters. That's a political decision, but anyhow, okay. So for the last decade or so, HPC has kind of been able to ride on the coattails of the enterprise computing, enterprise hardware. You know, a few mods here and there to an enterprise system, and you can use it as an HPC system, okay? But I'm not confident that's going to continue. For example, already the CPUs have millions of transistors dedicated to virtualization, which we don't use. The transistors are sitting there, using up power, possibly failing. I don't want them, okay? But we're stuck, and there's going to be more of that as enterprise goes off in a different direction. Enterprise is not doing HPC so much. They're more supporting mobile apps, you know, that kind of stuff. And HPC isn't a big enough market to drive the development. Like, how dedicated is Intel going to be to Mike if enterprise can't find a use for it? Okay, so, and to get around all of that, we're actually getting a quantum computer later this year.
Okay, just do you want to tell us why?
Because somebody thought it would be a good idea, and it's
now
NASA.
I got you in trouble with your management.
No, and you know, NASA's allowed to do some kind of research,
sure.
and this fits the bill. It's not going to be very big. It's like 512 qubits, and they're not all interconnected, so it's not really as good as 512 qubits, but it'll be interesting. And dig out your linear algebra books because you're not in Kansas anymore.
Thank you very much. So, Simon?
Thanks, Jim. I'm Simon Burbidge. I'm from Imperial College in London. Imperial College is one of the top 10 universities in the world. We've got a high percentage of postgraduate students and a large proportion of researchers. We just do science, technology, and medicine. We don't do computational high-performance French or anything like that. So it makes my job kind of easy. I run the high-performance computing service there. We have 3 machines, a small SGI-UV system, which is used for genomics, and the users paid for that. An SGI ICE system with 4,000 cores, which is used for running very parallel jobs, and a third cluster, which is made up of 14 distinct different node types, going back through history. It has about, I think, 12,500 cores at the moment that deals with the bulk of the workload. So I think Dell was a little bit pessimistic about the rate of growth of HPC systems and cores. I'm sure in the next 5 years they will get up into the stupid numbers. It's just, it's more or less given, I think. So we'll get to pettascale. But the obvious thing is we'll need highly parallel applications. So the hardware isn't an issue. That'll be there, that'll be working. It may not be terribly good. It might be a bit expensive. I think it'll be kind of more power efficient, because as far as I can see, that's what's driving the chip makers at the moment. So we might find that the power doom and gloom that's being predicted might not be quite as bad as potentially it could be. Especially with the price of electricity in the UK, because nobody can afford to run computers. I mean, you can buy one, you just can't switch it on. So a quick aside on GPUs, they're jolly interesting, and if you're a very bright kind of grad student, then you can write some really good programs that run really nicely on them. But for 95% of most of the kind of codes we've got, or people are writing, GPUs just don't kind of work. So I don't think GPUs in their current form are going to have a big future, just in certain specialised areas. I don't think the mic is going to be like a GPU. I think it's really just going to be like lots of cores. So that's probably the way we're going to get lots and lots of cores. I think the interesting thing to look at is the software side and how the users will react to having this large number of cores available to them. So what I think is that the users will run many more jobs of the type that they're running at the moment. Because what they'd really like to do is do the run like 20 times with some different parameters and some tweaks just to see what comes out, and make themselves feel more reassured that they're getting the right answer. A lot of the runs they do now, they'll spend 20 minutes trying to work out the parameters and just hope that it's right. So if they've got the opportunity to do many more runs, they will do that. Certainly a lot of the workload we see coming onto our systems is not highly parallel. We're seeing a big increase in the number of kind of parametric kind of studies where there's lots and lots of relatively small runs. A lot of the medical kind of programming is of that nature, where the total amount of CPU time is pretty high, but the different elements are so decoupled they can be treated as separate jobs. So I think I see the job mix changing over the years.
So you see it changing more towards more and more parametric studies versus these large, massively parallel types of things.
Yeah, I think we all think it's going to be the massively parallel ones that will continue to dominate, and I'm not sure that that's the case.
But what about the massively parallel jobs that are parameterized? Because that's what we see.
Yep, I'm sure we'll see that. There's even more doubt with a very large parallel job whether it's giving the right answers. And certainly if you change the number of processes it's running on, the numbers that come out can be slightly different as well. So if the user can get over that trepidation of getting different results, they might be interested to actually look at them in more detail. I think the important thing about huge parallel jobs is the current ones won't be able to be scaled up to the kind of size people want to scale them up to. So the user's going to have to look for new algorithms, new paradigms for doing their science, maybe going back and looking at some old maths to see if they can implement them better on much more parallel systems. And in fact, at Imperial College, we've just set up a centre for computational methods, where people from different domains can talk to each other about different techniques and different algorithms, just to see if they can learn a bit from their peers about doing something, calculations in a slightly different way to get better performance on a large scale. So I think it's software that's the problem, not the hardware. And clouds, I think we have one already. It's got like QSub, right?
Of course.
So that's all I have to say.
Okay, thank you very much. So Steve actually prepared some slides. He has to stay within his time, or at least try to. So I think, Krista, you're going to put his slides up? Clicker, yes.
Well, I had the benefit, our Chief Technology Officer gave a futures brief yesterday down in Monterey, so I could crib off of him. I'm Steve Scherr from DoD's High Performance Computing Modernization Program. My background is I spent about 20 years as a computational fluid dynamicist, dabbling in electromagnetics and visualization. And for the last bunch of years, I've been on the oversight and management side to try and do policies so that our users can continue to make effective use of our computers. The DoD, our program has about 3 petaflops of machines scattered over 5 sites and about, I think we've got 17 machines that we're going to have on the floor for fiscal 13. We have a wide variety of different technology areas, from fluid dynamics to weather modeling to electromagnetics to structures to bio type of effects, and so we've got a wide range of different algorithms, a lot of different folks. About 2,000 active users, depending on how we do our user count any particular year. Because of the fact that we do cover a wide variety of different technology areas, and we have a bunch of different users, our percentage of developers is relatively low. So folks are using codes that other folks have developed for them, or they're taking things in from academia. So it takes a long time for advances like, or possibilities like GPUs to filter in. Our folks are trying to get their jobs done, and most of them don't have time to dedicate to modifying algorithms or betting on a technology that they can't be sure is going to be around by the time they finish changing their code for it. So we've seen some limited adoption. We've seen some codes that have been able to take advantage of that, but we still have a pretty limited presence of that in our program.
Can we see his slides, Krista? What are you doing?
Oh,
there we go.
Gotcha. Not to figure out which is forward. So here's a picture. We divide up our user communities into different technology areas, a whole bunch of different things, as I mentioned. Here's our capacity slide. Oh, darn, I got it wrong. It was 6 petaflops, not 3 petaflops. And that's what's coming on board. We've got a couple of some big purchases that are being delivered and installed over the next several months. We have a decent amount of storage and archive. We're up about 23, 24 petabytes right now. Not as big as some of the big collections out there, but it gives us a lot of stuff to manage. Some of the things we provide to our user community, we look at different codes and performance on different systems. This is sorted from top to bottom, basically in terms of age of the system. So you'll see that most of the codes run faster on the newer systems with the faster processors. No big surprise, but there are certain codes that take advantage of different architectural features, whether it be interconnect or other things, and have different performance properties. So that's something that we try and keep our users informed about, but we don't compel them to go to any particular place other than by how many hours are available on different systems. What we see for the future are a bigger growth in the area of interactive workflows. So I was really interested in what Greg was talking about in terms of responsiveness. We heard this morning about business imperatives and kind of the small manufacturer might not be taking advantage of HPC. Well, we see that inside of DoD as well. We've got the people who know what they're doing with HPC, people who are never going to be able to use HPC, and we believe there's a whole big missing middle there of folks that could profit from using HPC but don't know about it yet. So we want to make things friendlier, the same kinds of things that the Altair folks were talking about with Compute Manager and the related technologies there. We're seeing more on data-intensive things. So I've got a couple illustrations here. Here's our Sea Eagle folks. That's the Air Force's program for approving stores, things you hang on wings so you can drop them off or fire them at people. And we have to qualify the airplanes in order to be safe to fly. And so when they have work that they need to do, they need to kind of get on it and do it, but it's unpredictable in advance. We hear that from a lot of our test community. We just had a really great presentation about different imperatives for queuing. So I'm going to skip through this particular slide because I got stuff to think about. Here's another example of some testing we've been doing at one of our centers with doing some real-time processing of radar data. Most of our stuff, almost all of our stuff is research related, but there's definitely a lot of growth within DoD for bringing things into the operational front and working with data on the fly. And so I also agree with my colleagues here that the real problem is software.
Of course, see, the software vendor has to hear this.
And taking advantage of things. As we look at our job mix, I don't think I have a slide on that. We see 90-some% of our jobs are down in the 1 to 8 core range. We see 60% of our cycles are up at the high end with the really big jobs, and we see the largest scalable users continue to scale and continue to grow, but the bulk of the work is sitting down at the low end. Whether it's parameter studies, whether it's things that just don't scale beyond 16 to 32 cores in their current form. A real growth area that I see as the machines get bigger is in the area of optimization. We've got people taking the really big multi-physics analysis codes and running those multiple times and really being able to use the power of the technology to improve that and improve designs really fast. So some of the things you showed yesterday, Jim, and we've seen some examples of that, we're starting to see our folks do that. So we're looking for tools that will help them either manage their gigantic parameter studies better or to manage their optimizations better.
Hyper study.
Right.
Yep.
Okay. And I think that's probably all at one time.
Okay, well, thank you very much. As the software vendor, I'll try not to take too big of a cut at customers, but we often will go to a customer and they bought a bunch of GPUs, and then they turn to us and they go, make them work good. And the reality is that for our applications, we've done a lot of testing with GPUs, and it's just simply not the right solution, right? On the other hand, you talked about interactive workflows, and we see cloud, if you will, and a lot of the utilization is sort of a return back to the way things were, if you will, 30 years ago, where people are running their interactive codes in the cloud, I guess, or on the servers. And so graphics nodes that are driving these kinds of operations absolutely are going to make more and more sense. So thank you very much. So Bill, you have the microphone. Does anyone in the audience have a question? Okay. Bill, walk over to someone with their hand raised, see striped shirt. Introduce yourself, please, and tell us who you're addressing the question to.
Cameron Haar, Fleet Numerical. This is for Steve. There's a lot of systems in HPC, MO, DSRCs. Is there an average utilization among those systems? Or is it a pretty big, mix? Just curious what the utilization is.
The bulk of our unclassified systems usually get reported out at an 80+% utilization rate on a monthly basis. I talked a little bit about that with Vincent yesterday. So from a user's point of view or a manager's point of view, a node's only busy when it's computing or being charged for time. From a scheduler's point of view, it's busy when it's being held so it can fulfill a request. So In terms of nodes being busy, we see extensive backlogs of jobs waiting to process on most of our systems. So we know we're close to our capacity, and maybe we could modify our queue structure a little bit better to get things through. So that's why we come to places like this to learn more.
Pretty good stuff.
Any other questions? So Bill, you're supposed to be a visionary. I gave you that CTO title there. Give us a little bit of what you see in the future. Come on up so they can see you when they throw tomatoes.
Right, so I don't actually have any computers though, so. So first, I was thinking while you guys were talking, and I was thinking to myself, okay, so cloud. Cloud is both a really cool opportunity and it's sort of like this curse, right? Because it's an opportunity in the sense that Amazon is making stuff that's available for like a penny an hour. And it's a curse because the people who are seeing that are the people who are spending money, not the people who can use the penny an hour systems. And so it's forcing us all to do, so it's a, I mean, I actually see that more as a curse in the HPC world than as an opportunity. But the opportunity is, and I heard a couple of times here, is on the whole cloud side, the whole cloud word is actually doing a couple things that I think are really powerful and useful. So one is it's actually making us define a better interface for our users, right? And it's nothing to do with cloud, it's just creating a better UI. Hey, great, that's great. So that's actually a fantastic opportunity. And the other one is it's actually making us consolidate some stuff that we had lying around that was really inefficient. Because now there's no way you can justify this thing sitting there that's getting zero utilization. And you're like, and look, you can point to your management and you can actually force some team that wanted their own thing. So it's helpful, it's not helpful. So that's not really visionary, that's that's my satirical look at cloud.
But that's right. I mean, my son's in his second year in an engineering program in college, and he went to science and tech high school, and the idea of he enjoyed his first computer programming class, but the idea of writing codes to do analysis is alien to him, and he wants to use tools that are out there, and he doesn't care what computer it runs on as long as he gets his answer. And I certainly see that from 80% of the users in our area. Is the important thing is getting the answer, and the details of what's going on in the back office are not as interesting to them. So providing the right kind of interfaces to reach out to those communities and to folks who can really make use of it is a really important stage for us.
I'd like to add go on with that, but something I've seen change recently and I expect to see change more. You've probably read in the newspaper about the Kepler project that's finding planets around remote stars. Okay, and Kepler does a lot of their analysis on our computer. They're using MATLAB. I kid you not, they send in jobs that ask for 100 nodes. They send in a whole mess of them at once, so they typically are running 1,000 nodes worth of MATLAB when they're doing this. Within the jobs, they are sequencing individual serial analyses, running the MATLAB, compiled MATLAB code. But it's in MATLAB because that's what they think best in. And computers are fast enough now that we can do it that way, and it's productive. And that's different. You wouldn't have thought of running tens of thousands of MATLABs in parallel, well, not exactly in parallel, but using a supercomputer to run MATLAB just wasn't thought of. But it's now, and it's good. It's good for them. They can change their algorithm. They realize, oh, we've got a mistake here. We have to go back and reanalyze these data, and they change their little formula, little recompile, and off they go. And it's really great for them.
I mean, in the end, brute force is really great, right? No, but it is, because you can be really elegant and write this elegant code, but sometimes brute force is really the best way to do something. And if you don't have to worry about the resources, then that's great. Oh, we have somebody with a question. Uh-oh.
Actually, it's in the comment that it's not that new. the first person who used a spreadsheet, or every programmer, like I was a programmer when spreadsheets came out, and said, oh my God, these things are so inefficient.
Can you introduce yourself? Because
I'm sorry, I'm David Rowland. I work with Dale at IES.
Okay, thank you. So are there any other, there's no other questions for this illustrious panel? Okay.
I have an observation while he's waiting.
Okay.
It would be nice if Altair, or somebody, but Altair would be nice because you've got PBS, came out with a package to allow users to package serial runs together, go out, grab a mess of nodes, do their parameter studies.
We have that. It's called HyperStudy. So, yeah, so we have,
great.
Altair has,
You need to advertise.
you know, and by the way, we do. So one of the things that we're going to do next year and going forward is we do a conference every year, and we do it in about 9 different countries. And we have an average of, I don't know, 500 people, 500 users attend each one. And we do PBS sort of separately, and we have some other things as well. And starting next year, we're going to change the name from the HyperWorks, which is that suite of tools, right, to the Altair Technology Conference. We'll try and do some tracks. So, for example, we can do a track for, you know, PBS and you know, all the IT stuff. But a lot of what we're talking about is all the things that you guys actually care about, and a little bit of the chaos of learning, you know, what people are using, such as HyperStudy. We have a product called HyperMath, which basically is MATLAB. It's all been written over the last many years, but very, very big effort on it. There'll be a Simulink companion that we're going to release in the first half of next year. We've been working on it for years and years. We spun it out of the Research Institute in Ria in France. And we took the whole team out of there, and they're in our office in Paris the last 3 years. So, you know, there's like a lot of different technology that I think really plays, and having sort of exposure, and the exposure goes the other way, because I think a lot of the users would really benefit by understanding a little more of what goes on, you know, in the data center world. So yes, we have HyperStudy. You guys should be using it. It's a great product, actually. And it's actually, I'm not sure whether the Altair folks know it, but HyperStudy is one of the most used. Doesn't get a lot of as much attention, but it's actually one of the most, because we track usage now because of the partner alliance. It's actually one of the most used products in the portfolio and growing rapidly. So, and it's because it's useful. So yes, there was a question from Venkat, right? Oh, okay.
I just got a question. So how does open source affect each of your organizations, or does it?
How does open source affect? Well, we're Linux-based, so almost all of the system software is open source. PBS obviously isn't, well, yeah, but we have source. Okay. We use commercial applications that are not open source, mostly for pre and post processing. We don't have that many commercial applications that run out at scale. And certainly when we're looking for things, we prefer open source over commercial, unless the commercial has a significant advantage, or sometimes it just has a large enough user base that even though there may be an open source equivalent, it's just simpler to license the commercial.
Actually, I don't mind hearing from you as well, but I'm curious on the open source question to ask a guy who's probably primarily using commercial codes, because I imagine at Chevron most of the codes are like VIP and Eclipse and those kinds of codes, right?
There's quite a bit of commercial code and certainly a lot of homegrown Chevron developed application. We have no problem using open source software. I mean, I mentioned Lustre. Lustre's open source, you know, and that was primarily our largest parallel file system. So as long as we obey all the rules about licensing, we don't have a problem. We'll look for the best solution for our problems rather than whether it's open source or a commercial product. But we always look for supportability too. It has to be supported. You know, with Lustre, there were companies, Lustre developed by a company called CFS originally before it became Sun. So we were buying support from them. You know, Linux itself is open source, but we buy support from Red Hat. So.
Right. As a software company, obviously, we have our battle, you know, against open source, and what we generally find in the marketplace is that there's a perception, oh, it's open source, so it's free. But the reality that ends up happening is, you know, if you really want to use it in a commercial kind of setting, you end up buying support, and it's actually at least the same cost and often more because there's other challenges that go along with using that kind of code. So,
but again, it boils down to what is the best solution for the company.
Absolutely.
And you know, if that's an open source solution plus we buy the support, then that's what we'll do.
Absolutely.
You know, I go back quite a few years to Open PBS. It was free, but it sucked. So you get about 16 nodes and it doesn't work. So we have no choice. We went. As high as 16 sometimes.
Actually, that hurt us early on, right? I mean, when we were coming with the commercial version, there was a perception in the market about that. It took us a while to, I know that code, that's not good. No, this is a code that has hundreds of man years of additional, development on it. So yes, I hear your pain. Simon, did you have something you were going to add on the open source?
Yeah, so I suppose if you look at all the code running on our systems, the vast majority of it is open source because it's research code. And research is collaboration. However, in terms of running services where you want something, like a batch system to be reliable and to be able to operate on the size of system you want, the choice is either something that falls over all the time or something that doesn't. So we have PBS Pro which doesn't fall over.
I should have let him talk first.
Some other examples are that for example, we have the Intel compilers, and the reason why we have those is because the code it generates goes faster, so we get more performance. There's a good reason to do that. So I think we make our decisions in the same way everybody else does. It's just that most of the code is research code.
Of course. Steve, did you have a comment on that?
We're pretty much the same. Support's important to us as providing things to our customers. On the research side, there are community codes in certain areas that are open and have community support. But the important thing for our researchers is that they have codes that are validated and verified, and you don't always have communities that are doing that for those types of codes. So they'll stick with the devil they know.
Is anybody? Yep. Vincent has a question back there. While they're doing that, may I ask one, like the dumb CEO question? That this is going to sound really dumb, so sorry. I go way back buying computers and using computers. It's a long time, and I've bought every kind of computer in HPC you can imagine, really. Early days it was all custom, processors, and it was Crays and floating point systems and convex and all that. And then it's really shifted all to commodity, technology, right? And I heard a little bit of a complaint that the commodity technology is all driven by enterprise applications as opposed to HPC. Do you see, because of that, a kind of opening, if you will, a business opening that starts to open up? Because, that's what businesses do, that's what entrepreneurs do, is they fill gaps, right? Where a new trend emerges in 5, 6, 7 years to starting to create more custom, hardware technology again. Who wants to answer that? Okay, the brave one.
So
the rest wanted to just tell me how dumb I am to even ask that.
The problem is the software. If you want to run this is good. If you want to run commercial software, it's got to be for a commercial hardware. I'm not going to get MATLAB compiled for something.
Yeah, but in our space, if the best code is coming out of, the best hardware is coming out of Cray, and it's a custom, vector machine, whatever, I'm going to probably want to support that.
But it's more expensive for you to support that than to add support for that than to continue supporting the hardware that you're going to have to support.
But if it's worth it to you, you'll pay more, and so I'm a businessman, and I'll fill that niche, right? Okay, so I'm a cockeyed optimist. Is that what you're saying?
I have one comment. I'll bring up the green agenda because that's politically desirable. So I think we're pretty much stuffed in HPC at the moment because the processors we're using are not designed for HPC. When you're running your scientific code on an Intel or an AMD processor, you're using like 5% of it, and the rest of it is wasted. So if the green police were to come along and actually understand that and look at it, they'd be very cross with us because we were wasting so many resources to get so little result. We don't have a choice, but it's not an efficient way to do what we're doing. So if there was somehow some swing back to processes that were more aligned to the kind of work we do, that would be an advantage.
I'm going to remember this question. Vincent, you had a question.
I had a few comments, but I'll keep it to actually that point about MATLAB and really ask in the context of HPC in the next 5 years. You all brought up basically the types of workloads you're running, and they center around MPI. And I'd like to hear more your thoughts on I'll tie in sort of the other comments, which is the last couple of years have seen tremendous changes in user interface alone. So if you take the mobile devices and the way people and young people are expecting responses and responsiveness, and tie that back into the future of MPI and the way that research is conducted. So I'm just curious to know, to have your thoughts, your respective thoughts on whether you think MPI is here to stay, or if that model of computation is being challenged by big data or other approaches.
Tough question, I think. I think MPI will be around for a long time because it's the most popular and widely used way of parallelizing a scientific code. And we have to go parallel because of the many core. So it will be around. I think it doesn't scale at the high end. When we get to petascale, it's going to be a problem, and people will be kind of circumventing lots of MPI by doing things to try and avoid that overhead. So it would be really interesting to see what kind of paradigms come out of that kind of effort. And MATLAB, on the other point, I don't run MATLAB because I don't have licensing for it on my HPC, which is kind of convenient. So I said to my users, well, if you want to run MATLAB on the HPC, you can pay for the licenses for it. And everybody I've said, you can do that, give me the money, they've gone off and they don't want to run MATLAB anymore.
Hypermath. Because that is the opening, right? Why did I write hypermath? Because MATLAB is so ridiculously expensive when you want it to float, right? So, absolutely.
So I was an early MPI adopter, and I agree. There are lots of problems where domain decomposition works well and message passing can serve you well. There are other places where if you use a SIMD architecture that you really have to kind of squirm to try and fit things into that paradigm. But to get performance out of an exascale or near exascale class machine, you're going to need problems that are suited for that. And there's algorithm research going on, but I don't know if the maturity of our physics models is going to support that. I'll be an optimist in 100%. You asked questions earlier today about shared memory systems, and my program in its early days went through some significant effort in forcing people away from vector machines, and then migrating over to clusters where shared memory was harder to get, because you can always emulate it. It's the power of the marketplace and the commodity processing that's going to keep us there.
Great. Is there a last comment? No. So let's have a round of applause for.